Hello everyone. In today's video, I will show you how to use one of the generative component in the EvoMass. There are three components in the EvoMass, which is the additive one, the subtractive one, and the tower one. The tower one is not very relevant in the whole EvoMass, but if you want to use, you feel free to try it. Uh, this video will be talk about how you can use the additive foam meshing component to generate the building meshing you want to use. So let's go into the topic. So here is the one of the, let me delete this one and create a new one. So here is the default setting of the additive foam meshing component, and we use this default meshing to generate our first design, just like this. And you can click here to create many different design variants as you want. And I will talk about each of the section to tell you what is the purpose of this parameter and how you can use this parameter to control the generated design. The most important parameter is this free one, is define the boundary of the how this unit mesh to fill the space. For example, if you want to create a large building meshing design, and you can create the span number x in the x and the y direction. As you can see, the building is become larger. And if you want, and if this is a high-rise building, you can increase the floor number. Just like this. And the second useful function here is the enclosure factor, which determine how this unit mesh to fill this divided space. If we decrease this number, the building will become a little bit thinner. And if we hold on, so let's generate some example. And if you increase this number, the building meshing will become more fat. Yeah. Let's take to the default setting here. So in the architecture design, you also want to control the geometrical complexity of the building meshing. So if you want to make the building looks more simpler, you can use the number of the unit mesh here. For example, if we set here is a 3, and there will be usually have a more the design will be much more simpler. And when you increase the number, the building meshing will be a little bit more complex. But you also should be aware that when you increase the number of the unit mesh, they will increase the parameter to control this building meshing. If you're just using this to generate building design variant, this is okay. But if you put this into a organization process, there will be a problem. If you, for example, each of the box of this Unimax will require 6 parameter to define the starting point and the end point. So if here have a 7 Unimax, it means that they will have a 42 parameter. And if the parameter is too large, if we use the number of the parameter is too large, it will cause some trouble for the optimization algorithm to search for the optimal solution. So should be aware of the number. And if you're using such a large number of the unit mesh, you may need to increase the number of iteration in the optimization algorithm. All right. And another way to so the next topic is how to how to control the size of this building meshing. Except for you can use the enclosure factor, you can also use this real size constraint. This will be much useful for the layout design. Let me show you how to use it. For example, we generate, for example, like a kindergarten design. Here is set into a full floor and 15 span number in both directions. And here you can see the building is just like a factory or some kind of thing. And this cannot like the thing you want to like the sport skater in the building plot. And in this case, you can use the real size constraint to create the building you want. Just like this. The the real size constraint means that in here it defines each of the building the unit will be ranged from 2 to 4 floor, and the horizontal size will be ranged from the 2 to 4 column grids here. So if you increase the horizontal size here, you can see the change. Yeah, it will become bigger. And similarly, if you, for example, increase the number here first, and you can see the building, the meshing is very small. And but if you create this number, for example, like this, and you can change the size of each of the unit mesh. In architecture design, the gross floor area is also a very important parameter in the building design. So the EvoMass provide you a constraint to control the area of the generated design. So, for example, in this design, you can see that here is tell you that the gross area of this generated design is 54,000 square meter. So let's set this into like 40,000. So the algorithm will be automatically address the building meshing to make the final design to as close as to the target area you set. For example, here is a kind of 42,000 square meter, and we change another one. And here you can see it's 39,000. But just be aware that if you enable this function, it will cost more time for the algorithm to calculate for the accurate design variant to satisfy the target gross area. So if you use this in optimization, design optimization, you will delay the whole process. All right, next move to the advanced setting here. So the advanced setting here have some more complex but more interesting function that to help you to more control or define the generated design. We talk about the first one is the interfering point. If you set the point here, they will to make the if you want to make the unit mesh more closer or away from the defined point, you can use this function. For example, in this case, because this is a positive number, so they will be closer to the interfering point. But if you we just generate another one to see. But if you make this into a negative number, the building will be away from the interfering point. And if you don't want to use this interfering point anymore, you just click the clear point here and to click the set parameter again. And here, the other useful function here is the separation control, which make each of the unit mesh more separated from each other in both directions. You can, for example, select in the horizontal direction, and the building meshing will be separated from one another in the direction in the horizontal direction. And if you use the vertical one, it will be more separated in the vertical direction. And of course, you can use this to make the UniMesh separate in both directions. Okay, let's move on to the next parameter. Here is the free constraint. Usually you can use this at the same time or disable it at the same time. If you disable all these constraints, there will be result in some floating building meshing, just like this. The whole building meshing will be float in the air. So usually there is invisible in the architecture design. So usually you will try to prevent this design and so you need to enable this constraint to make the building meshing to go down to the earth. All right. The next one is the cutting boundary and the adding boundary. The cutting boundary and the adding boundary, I already explained it in another video, but I will talk about this a little in this video. So in regards to the cutting boundary, you only need to input a curve as a boundary of the generated design. So all the building meshing outside the boundary will be deleted. This function will allow you to create a very complex boundary of your building block. Let's clear the cutting boundary. On the contrary, the adding boundary allow you to set an additional meshing in the generated design. Usually, if you generate this building meshing, like for example, a podium of a high-rise tower, you may need to create a tower by using this function. As you can see, the tower will be always there. An interesting application of this function is that if you move the tower here, and you can see some of the interesting interlocking meshing. Usually you can find in the real world architecture design have this type of the cell shading features. You can combine this function with the boundary here. For example, you set this to the 15th floor and to do a horizontal separation control. Yeah, you can see this type of the building meshing here. All right, let's move to the next operator. Let's delete this. And the second to the last one is the open ground floor and the fixed open floor, which allow you to set a steel in the generated design. And also some floor here will be cut off if you divide it. And the last function is the fixed wall. With fixed wall will allow you to create different types of the building footprint. Let's set up here. All right, here has our generated design. If you want to, for example, cut the corner from here, you can enable this function and then to set the size of the cutting area. All right, you can see that the 0, means that the starting point here, and the X and the Y define the size of this cutting boundary. And of course, you can change this number and make entrance in the building. And in some cases, you want to have a 2 entrance, you can define the second entrance like this. Oh, since a bug shows. I'll try to figure out this. All right, you can see that the 2 entrance is shown in the generated design. All right, this is today's video. I hope you enjoy using the EvoMass, and I will see you next time. Thank you.